Today we're going to talk about division, and we're going to go over a strategy that we can use called partial quotients, and hopefully we can also go over the standard algorithm for division in 5th grade. But before we get started, I want to go over some vocabulary. So division is essentially the inverse operation of multiplication. In multiplication, you have two factors multiplied together, so factor times factor, and this results in a product. And if you think about it in the terms of part, whole, what we're looking at is two parts in a whole. I'm going to multiply two parts to get the whole. So what I'm given are the two parts. Well, division being the inverse means I'm given the whole and one of the parts, and I have to find the missing part. And so that whole is our dividend. That's our number that we are going to be dividing up, breaking apart by a divisor to get a quotient. So in relationship to our multiplication problem, the divisor and the quotients then are those factors that we started with. So when you're multiplying a set of numbers, and it's going to repeat a certain amount of times to get that product. So when you're dividing, this divisor, depending on which part you were given, is either going to be that number of sets or groups, or it's going to be how many are in one group. Depending on the problem and the verbiage and what it gives you. If it gives you the number of sets, then your quotient is going to tell you, well, how many's in one of those sets. If it tells you how many's in each set, then your quotient's going to be telling you how many sets you have. So, knowing the vocabulary, let's look at an actual division problem. So, in 5th grade, our division is dividing by two-digit divisors. So, meaning that these numbers could be anywhere from 10 to 99. The problem that we're going to start with is going to be 62 divided in to 8,542. Okay, I'm going to zoom in so we can see a little bit closer what we're doing. All right, now, I don't know about you, but I don't know all my factors of 62. So where do I even start? Normally, what I would see on a student's paper is random guesses and a whole bunch of multiplication problems filling up this white space, getting them nowhere and taking them 20 minutes to complete one problem. So in order to combat that, using this partial quotient strategy, we're going to use what are called benchmark numbers. Okay, so our benchmark numbers are going to be 1, 2, and 5. Okay, and we're going to still create our T-chart, but instead of sitting here and coming up with all the factors of 62 from 1 to 30, or however far we need to go, we're just going to use those 1, 2, 5s as benchmarks, and we're going to use those and look at the relationships between the numbers and the patterns of the numbers. So I know that any number times 1 is itself, so 1 times 62 then is 62. Now, any number times 2 is just doubled. If they are bigger numbers and you can't double them, then instead of having to come over here and do all the multiplication, just use the patterns. Break it up into its components into the expanded form of 60 and 2 and double them individually. So 60, 2 6s make 12, 60, add a 0. 2 2s make 4. So if I have 2 sets, then I have combined 124. Again, I don't know what 5 times 62 is, but my multiple of 1, I'm going to go up to 10 because that's just 1 times 62 with a 0 at the end, so 620. And I know that the relationship between 5 and 10 is 5 is half of 10. So if I take half of how many are in 10 groups, That's going to tell me how many's in 5 groups. If you can't do this in your head, again, use the same strategy. So you get 600 and you get 20 this time. But instead of going double, I'm going backwards. I'm going to divide it in half. So half of 600 is 300 and half of 20 is 10 to get 310. Now, we're going to keep going with these same patterns of numbers until I get as close to 8,542 without going over it. 620, we're not close. So we're going to go ahead and go up to 20. That's just 2 times 62 with a 0. So 124 with a 0 on the end makes 1,240. Then we're going to go to 50. 50 would be 310 with another 0, 3,100. Again, I'm still not close. So now I'm going to go to that next level of 1, which is 100. So that would be 62 with now 2 zeros on the end. Still not there, so let me just check 200. 200 would be 124 with 2 zeros. Well, now I'm at 12,000. 12,000 is definitely bigger than 8,542. So that's too big. So how do I use these benchmarks? I've made the benchmarks. Now what do I do? Now you're going to start from the bottom of your chart. You're going to work up the ladder. Because just like if you're counting out money, you're going to take big sets, as many as you can, and put them and count them out, and then you're going to move and go to smaller. You're going to pull out as many 5s as you can. Then you're going to put out as many 1s as you can. But you're going to start with that bigger number first. So I'm going to go as far down without going over, so that's 6,200. The number over here, your multiple, this is what I'm going to be subtracting from the dividend. Okay? Because this is what's happening when you put 100 pieces in each set. So these numbers on the right are going in my quotient. This is what I'm working with. So I'm going to decide to use the pair of 100 and 6,200. So that means that if I put 100 in each group, again, you can't put 1,000, so that's a 0 as a placeholder. 100 in each group, there being 62 groups, that uses 6,200 pieces. So just as if you were doing your standard algorithm of division, you're still dividing, multiplying, subtracting. So now that when you subtracting all the way across, no need to borrow in this set, you get 2,342. So now I go back to my list. This number, 6,200, is now too big. It's bigger than what's left. I can't use it again. If it were not bigger, you could use it again. You can take out as many sets of 100 as is possible and allowed by what's being divided. But in this case, it's too big. I can't use it. So I'm going to skip up to 50. 3,100 is also too big. I can't use it. So I'm going to keep going up the ladder. So I get to 20 and I see 1,240 and I see, well, that's really low. So I'm going to look on my list and look at the relationship, and I see that if I combine 10 groups and 20 groups together, so 30 groups, then that would be the same as adding 1,240 and 620, which is 1,860, which is still less than 2,343. So this time I'm going to take 30 groups out. 10 plus another 20, meaning 30 groups. I'm going to subtract. This time I do have to borrow, regroup, because you cannot subtract 4 minus 6. So we take from the 3, carrying it over. We're adding the 10 to the 4 that we already have. So it's 14 minus 6, not 10 minus 6, which gives me 8. Again, you cannot subtract 2 minus 8. So we have to borrow and regroup again. I'm adding that 1 to the 2. So it's 12 minus 8, which is 4. So I'm left with 482. So now I got to skip way far up again. I can't use 20. I can't use 10. I can use 5. And again, I'm looking at the relationships and see very easily that added together, that's 434. So I could put 7 in each group. 434, which 2 minus 4 you can't do. Let's borrow. Leaves me with 12 minus 4, which is 8. 7 minus 3 is 4. 4 minus 4, of course, is 0. So now 48, let me slide up a little bit. Okay, there we go. 48 is smaller than my divisor, so that means there's nothing I can do. I cannot divide 48 pieces evenly into 62 groups. So he becomes my remainder. So where do I get the answer? Well, up here in your quotient, you're putting it all together. You first put 100 in every set, then you put 30 in every set, and then you put another 7 in every set to get 137 pieces with a remainder of 48. So, how does this work with just doing the standard algorithm? Because you can still use these benchmark numbers. So let's move to our standard algorithm.